Hey everyone, and welcome to another deep dive. This time we're taking a look at the Pragmatic Programmer.
Oh yeah, the 20th anniversary edition.
This book's a classic. It's like the go-to guide for becoming a well-rounded, effective programmer.
It really is.
And we've got a ton to unpack, so let's just dive right in.
Let's do it.
Okay, so one of the first things that really struck me was this idea of taking ownership of your career, right?
Yes.
Like not just being a cog in the machine, but actually driving your own growth.
It's so easy to feel like you're just, stuck on autopilot,
Mm,
especially in those big organizations.
yeah,
But this book, it flips that script. It's like, hey, you have agency.
you have the power.
You have the power to shape your path, to influence your environment.
They even quote Martin Fowler in there, which is a nice touch.
They do.
He says, you can change your organization or change your organization.
It's a brilliant way to put it.
Right.
Like, you're not a passive passenger.
Exactly.
You're in the driver's seat.
Yeah. And that ties into another big idea. Don't live with broken windows.
Ah, yes. The broken windows analogy.
So powerful, right? It's like neglecting those small issues can lead to those massive problems down the line.
Imagine a building, right? With a broken window.
Yeah.
It's an invitation for more damage, for neglect.
That one little crack can bring the whole structure down.
Exactly. Now translate that to software.
Okay.
Those broken windows, they could be anything. Bad code, poor design choices, bad practices.
Oh, those shortcuts we all take sometimes, thinking, it'll be fine.
And then boom, technical debt explodes.
Yeah, it's like that snowball effect. One tiny flake, and suddenly you're buried.
So the key takeaway, fix those windows as soon as you spot them.
Be proactive.
Exactly. Don't let that entropy take over.
It makes me think of this one project I inherited. Oh, it was a nightmare.
Oh,
No comments, unused variables everywhere. It was like wandering through a jungle, blindfolded.
oof, I've been there.
If they had just taken the time to, fix those little things, it would have saved so much pain later.
Prevention is key. Always.
Absolutely. Now, speaking of being proactive, there's this great story in the book about stone soup.
Ah, yes. The classic tale.
What's your take on it?
It's brilliant, really. It shows how a catalyst can spark collaboration. Imagine these soldiers. They arrive in a village.
Okay.
Everyone's suspicious. Nobody wants to share.
Understandably so, right? After a war.
Exactly.
Yeah.
So the soldiers, they're clever. They start making stone soup,
Stone soup, like literally rocks in a pot.
pretty much.
Mm.
But here's the trick. They act as catalysts. They get the villagers involved.
Okay.
Oh, a carrot would really enhance this stone soup.
I see.
A potato, a pinch of salt.
And before you know it, you've got a feast.
Exactly. And everyone contributed.
It's like they tricked them into collaborating.
In a way, yeah. But it's a positive manipulation.
For sure. So how does this relate to programmers?
You can be that catalyst,
Okay.
You can encourage teamwork, break down silos, inspire people.
To create something greater than they could on their own?
Exactly. Like that delicious stone soup.
It's a good reminder that we're not just coding in a vacuum. We have the power to really shape our teams, our environments.
It's about being a force for positive change.
Now, on the flip side of that, there's the boiled frog analogy.
Yes, the cautionary tale.
Gradual decline, creeping problems.
That frog sitting in the lukewarm water
Doesn't realize it's getting hotter and hotter.
until it's too late.
Yikes. So how do we avoid being boiled frogs?
We need to be vigilant, to step back, to assess
For those subtle signs of trouble.
that growing technical debt, those bad habits.
It's about taking the temperature of your project, so to speak.
Regularly post checks.
Make sure you're not slowly cooking yourself.
Exactly.
Yeah.
Now, let's talk about something a little more positive.
Yes, please. The book talks about this knowledge portfolio,
Ah, a crucial concept.
like treating your skills as investment.
Diversification is key.
So how do we build this portfolio?
They have some pretty concrete recommendations, like
Yeah.
learning a new language every year.
A new language. Every year. That seems like a lot.
It is a commitment. But think of the benefits. Each language, it offers a new perspective, a new way of thinking.
I guess it's like learning a new spoken language. It expands your worldview.
Exactly. You become more versatile, more adaptable.
Able to choose the right tool for the job.
Precisely. And alongside those languages, a technical book each month.
Wild dives, huh?
Deep dives. Build that solid foundation.
And they also say to explore technologies outside your comfort zone, even if it doesn't seem directly relevant.
You never know where that next spark of inspiration will come from.
Always be learning, always be growing.
That's the pragmatic mindset.
Now let's talk about a principle that's close to every programmer's heart. DRY.
Don't repeat yourself. A classic.
But it's more than just avoiding duplicate code, right?
Much more. It's about ensuring that every piece of knowledge, has a single, unambiguous representation.
Okay, I'm following.
Imagine you have two parts of your code that validate user input.
Okay.
One checks the user's age, the other checks the quantity of an item.
So both are checking if a number falls within a certain range.
Right. But the knowledge they represent is different. One is about age, with its specific context.
And the other is about quantity, which has a completely different meaning.
Exactly. So even though the code might look similar, it's actually representing distinct pieces of knowledge.
So DRY is about eliminating redundancy in knowledge.
Not just code.
I see the distinction. It's about understanding the underlying concept and expressing it clearly and consistently.
You got it. That's the essence of DRY.
I had this one project where we had two separate functions for handling user authentication, almost identical.
Oh boy.
One for the website, one for the mobile app.
Classic case.
We ended up refactoring it into a single module, much cleaner, much easier to maintain.
DRY in action.
So we've talked about taking ownership, fixing broken windows, building our knowledge portfolio, staying DRY. What's next on our pragmatic journey?
Let's explore the concept of orthogonality. Imagine you're flying a helicopter, and every time you push the joystick forward to speed up, the helicopter also tilts to the side.
That sounds terrifying. Uncontrollable.
Exactly. That's what non-orthogonal systems feel like, when components are tightly coupled.
So, one change can trigger a chain reaction of unintended consequences?
Like a domino effect. You adjust one thing, and suddenly everything's breaking.
It's like those butterfly effect, but with code.
Now contrast that with an orthogonal system,
Okay.
where components are self-contained, independent.
Each with a clear purpose.
Think of those classic Unix tools.
Like grep, sort, cat.
Each one does one thing well, and they can be combined in endless ways.
The power of modularity.
Exactly. In an orthogonal system, changes are localized.
Yeah.
You modify one component, it doesn't break everything else.
It's like those compartments in a ship. If one floods, the whole thing doesn't sink.
Precisely. It's about reducing those dependencies, making those systems more robust, more maintainable.
So orthogonality is all about creating those clear boundaries between different parts of the system.
So they can evolve independently without causing chaos.
Makes sense. Now, what about navigating those ever-changing technological landscape?
Ah, yes. The challenge of reversibility.
How do we avoid those irreversible decisions that could lock us into a path that becomes obsolete?
To introduce those concept of tracer bullets.
Tracer bullets, that sounds intriguing.
Imagine you're firing a gun in the dark. A tracer bullet lets you see the trajectory.
So you can adjust your aim.
Exactly.
Mm-hmm.
In software, those are those small end-to-end pieces of functionality that you build to test your assumptions early on.
So not building the whole feature,
Yeah,
but a minimal version that touches all the key parts.
exactly. Validate your approach, identify those potential problems.
Before you invest too much time and energy
It's like a proof of concept, a quick and dirty prototype.
to see if your ideas are actually viable.
Precisely. Prototyping is all about embracing those imperfections,
Yeah.
focusing on those essentials.
I remember this one project where we went all in on a framework and then realized it wasn't a good fit.
Oh, the pain of sunk costs.
If only we had prototyped first.
It would have saved you so much headache.
Lesson learned. So, prototypes don't need to be perfect. They just need to serve their purpose.
Gather those insights, validate those assumptions.
Speaking of things that can be a bit tricky, let's talk about estimation.
Ah, the eternal struggle.
It's like trying to predict the future with all those unknowns and those inevitable surprises. How many times have we said 2 weeks and then it turns into a month or two?
It happens to the best of us. But the book offers some guidance.
Okay, I'm all ears.
They talk about the Program Evaluation Review Technique.
PERT. What's that?
It was developed by the U.S. Navy for the Polaris submarine project.
Wow. If it works for submarines, maybe it can work for our code.
The essence of PERT is to acknowledge uncertainty,
Okay.
to estimate with ranges, not fixed numbers.
So it will take between 6 and 8 weeks, rather than 7 weeks, guaranteed.
Precisely. And choosing the appropriate units for your estimates. If it's a month-long project, don't get bogged down in days.
Keep it high level. Exactly. It's about conveying the intended accuracy.
And being transparent about those uncertainties.
Right. No more setting unrealistic expectations.
And along with those ranges, explain your rationale. What assumptions have you made? What are those potential risks?
Have that open and honest conversation with stakeholders.
So everyone's on the same page.
Now, this next one might seem a bit counterintuitive. In today's world of fancy databases and cloud storage,
Hit me with it.
the book advocates for using plain text.
Plain text. Really, in the
Sure.
age of XML and JSON.
Yep. They make a strong case for it, highlighting its longevity, its portability.
I mean, it's simple, it's universal,
Exactly. It's survived decades of technological evolution.
not tied to any specific software or hardware, so it's future-proof.
They talk about the Unix philosophy of small, sharp tools
Each tool doing one thing well,
and operating on plain text.
creating a flexible, adaptable system.
Exactly. So even as technology changes, your data in plain text can be easily accessed and manipulated. It's like a universal language that transcends those technological barriers.
Now, speaking of things that are essential for long-term success, let's talk about version control.
Version control is a lifesaver. I can't imagine working without it.
It's those safety net, those time machines.
Those collaboration tools, those historical records.
It's about so much more than just undoing mistakes.
I've seen projects where they try to do version control manually, copying files, renaming them.
The recipe for disaster.
Total chaos. Version control systems are essential.
They are, and not just for code. Documentation, configuration files, everything.
Keep it all under version control.
A single source of truth.
Now let's talk about something that every programmer has to face. Debugging.
The inevitable bug hunt. But the book reframes it as a process of investigation, like a detective solving a mystery.
So not just random trial and error.
No, it's about being systematic, gathering clues.
I'm intrigued. What are some of those detective techniques?
First, you need to be able to reproduce those bugs consistently.
Oh yeah, those elusive ones. That only appear under very specific circumstances.
Those are the worst. But once you can reproduce it, you can use a technique called binary chop.
Binary chop, like cutting something in half.
Exactly. You systematically eliminate possibilities like narrowing down a search range.
Until you isolate the source of the problem.
Precisely. And it's just as important, don't make assumptions.
Don't assume it, prove it.
Exactly. Verify those assumptions. Test thoroughly.
No jumping to conclusions.
Now, let's dive into the world of text manipulation languages.
Text manipulation.
They compare them to routers in woodworking.
Okay, I'm curious about that analogy.
Routers, those powerful tools for shaping wood. Text manipulation languages like Perl or Awk. They're those power tools for text.
Code generation, data transformation, automation.
They can do some amazing things.
But you got to use them carefully.
Exactly. There's a learning curve. But the payoff can be huge.
So another tool for the pragmatic programmer's toolbox.
Speaking of tools, let's talk about design by contract.
Design by contract. Sounds formal.
It is. It's about defining clear expectations for how functions and classes should behave.
Setting those boundaries, those rules of engagement.
Exactly. Using preconditions, postconditions, and invariants.
Okay, break those down for me.
A precondition is a requirement that must be met before a function can run. Like, this variable must be positive.
A gatekeeper, making sure everything's in order.
Precisely. A postcondition is a promise that the function makes about the outcome. After I run, this will be true.
Ensuring it fulfills its end of the bargain.
And an invariant is a condition that must always hold true throughout the lifetime of an object or a system.
Like a fundamental rule that governs its behavior.
Exactly.
Oh.
And violating any of those contractual elements, that's a bug.
So design by contract is about creating robust, predictable code.
Precisely. It's about making sure everyone plays by the rules.
Now, this next one might seem a bit strange. The principle of crash early.
Ah, yes. It might seem counterintuitive, but sometimes crashing is the best course of action.
Wait, really? Why would we want our software to crash?
It's better to crash early than to continue running in an invalid state.
Okay, that makes sense. Damage control.
Exactly. Prevent data corruption, unpredictable behavior.
It's like hitting the emergency stop button
Yeah.
before the whole factory explodes.
They talk about languages like Erlang and Elixir that embrace the let it crash philosophy.
So it's not about preventing failures altogether, but about handling them gracefully.
Right. They have supervisors that can restart those failed processes, isolate the failures, prevent cascading problems.
Because safety net.
Exactly. Design systems that are fault-tolerant, resilient.
This has been an amazing overview of the Pragmatic Programmer so far. We've covered so much ground.
But there's still more to explore.
So much wisdom packed into this book.
And we'll continue our deep dive in part 2.
Stay tuned.
All right, so picking up where we left off.
Yeah, let's dive back in.
We were talking about decoupling, right? Creating those systems where components are loosely connected.
Reducing those dependencies, making it easier to change things without breaking everything else.
Precisely. Yeah. And one of the key principles they highlight is tell, don't ask.
Okay, tell, don't ask. I've heard that before, but I'm not sure I fully grasp it.
It's about how objects interact. Instead of asking an object for its state and then making decisions, you tell the object what you want it to do.
So less interrogation, more delegation.
Exactly. Let's say you're working with a shopping cart object.
Okay.
In a tightly coupled system, you might have code that reaches into the cart.
And pulls out the price of each item, then calculates the total.
Right, but with tell, don't ask, you'd have a method on the cart, like calculate total price.
And you just tell the cart to do its thing.
Exactly. It handles the details internally.
So you're abstracting away those implementation details, letting those objects manage its own state?
It's like those well-defined APIs. You don't need to know how they work inside.
You just trust them to do their job.
Exactly.
Yeah.
Trust, but verify.
Yeah,
Always have those tests.
of course. Now, what about those things that can make code really messy?
Like global data.
Yeah, those variables that can be accessed from anywhere.
They can be a real source of headaches.
It's like a recipe for spaghetti code.
Yeah.
Everything tangled and interconnected.
And external resources, like databases or file systems, they can create those hidden dependencies that are hard to track.
It's like trying to understand a machine by looking at only one tiny part.
The book encourages us to encapsulate those things.
Control access, minimize those unintended side effects.
Keep things tidy, well organized.
Now, for something a bit different, transformational programming.
Ah, a fascinating way to think about programming. Shifting the focus from objects and methods to those flow of data.
So it's about those transformations that data undergoes.
Exactly. Like a pipeline. Data flows in, gets transformed, flows out.
They give that example of the anagram program.
Right. You start with a word. Generate all possible subsets of letters, create unique signatures.
And then you can look up matching words in a dictionary.
Exactly. A series of transformations, elegant and efficient.
I like how this approach breaks down those problems into those smaller steps.
It can lead to simpler designs, better error handling, less coupling.
Speaking of challenging traditional OOP concepts,
They have some interesting thoughts on inheritance.
inheritance. But isn't that like a core principle of OOP?
It is, but they argue that it can be overused, leading to those tight coupling and obscuring those relationships between concepts.
So just because a car is a type of vehicle doesn't mean it should inherit everything from the vehicle class.
Precisely. They suggest exploring alternatives like interfaces, delegation, mixins.
To achieve code reuse in a more flexible way.
Exactly. Interfaces define a contract, the what, but not the how. Delegation is about passing responsibility to another object.
Mixins are like those add-ons, providing additional functionality.
Right. It's about choosing those right tool for the job.
Now let's talk about something that's becoming increasingly important. Concurrency.
Ah, the art of doing multiple things at once.
Essential for building responsive and efficient applications.
But it comes with its own set of challenges, especially when dealing with those shared resources.
Which can lead to race conditions and those unpredictable behavior.
It's like a chaotic dance floor. Everyone trying to move at the same time, bumping into each other.
They discuss those techniques for managing those shared resources. Locks, semaphores, other synchronization mechanisms.
Tools to coordinate access, prevent data corruption.
But they also warn against overusing them because they can introduce complexity and performance bottlenecks. It's like traffic management. You need those rules to prevent accidents, but too many can cause gridlock.
They also introduce those concept of temporal coupling.
Temporal coupling.
It's when your code relies on a specific sequence of events.
So one thing must happen before another, which can limit concurrency.
Exactly. They encourage us to break those temporal dependencies where possible.
Design code that can execute in parallel.
Like a well-choreographed dance, everyone moving in sync but independently.
They introduced those actor model as a way to achieve this.
Actors are those independent entities with their own state and behavior, communicating through messages.
Like a team of specialists, each handling their own tasks, coordinating their efforts.
And this helps to avoid those tricky synchronization problems.
Because each actor has its own private state. No more shared data, no more race conditions.
They also talk about supervisors, actors that monitor other actors, handling those failures.
Like a manager making sure everything runs smoothly.
Exactly. Building those resilient, fault-tolerant systems.
Now let's shift gears to testing,
They talk about property-based testing.
which complements those traditional unit testing.
It's about testing those properties of your code, rather than specific scenarios.
So instead of saying, if I input 5, I expect the output to be 10, you'd say the output should always be twice those input.
Exactly. Testing those relationships, those invariants.
Like in that warehouse management system example.
Right, the total quantity of an item should never be negative.
Or each item should have a unique identifier.
Precisely. Property-based testing helps to catch those edge cases.
Those subtle bugs that might slip through those cracks of traditional testing.
Now, let's talk about security.
A topic that's more important than ever.
The book stresses those need for a security-first mindset.
Not just an afterthought.
They debunk the myth of security through obscurity.
Hiding your vulnerabilities, hoping no one will find them.
Like hiding your key under those doormat.
Not a very effective strategy.
They discuss those basic principles. Minimizing attack surface, following the principle of least privilege, securing defaults, encrypting data,
And of course, keeping everything updated.
patching those systems, staying ahead of those threats.
Because the security landscape is constantly evolving.
Exactly. Now let's shift gears to something a bit more stylistic.
Naming.
Yes. The art of choosing those right words for all those elements that make up our code.
It can be surprisingly difficult to find those perfect names.
They argue that good naming goes beyond just aesthetics. It can actually deepen your understanding of those code.
Because if you're struggling to name something,
It might mean you don't fully grasp its purpose.
they emphasize consistency, honoring those language and those community conventions.
And avoiding those overly clever or obscure names.
Write code that's easy for humans to understand.
Clarity is key.
Now, for those essential process of keeping code healthy, refactoring,
The art of improving code without changing its behavior.
like cleaning and reorganizing your house,
Making it more livable without changing those layout.
they emphasize small steps, backed by those tests.
Don't try to refactor everything at once.
Refactor early, refactor often, manage those technical debt, prevent those code rot.
Like regular maintenance for your code base.
Now, let's talk about a methodology that's gained a lot of traction. Test-driven development.
PDD, writing those tests before those code, helps you clarify requirements, design better code,
Like having those blueprint before you start building.
but they caution against treating TDD as a dogma.
Meaning it's not always those best approach.
They share a story about Ron Jeffries and the Sudoku solver.
Oh, yeah. What happened there?
He got bogged down in the TDD process, lost sight of those bigger picture.
So it's a tool, not a rule. Use it wisely.
Now, onto component-based development.
Building software from reusable components like Lego blocks.
They draw a parallel with integrated circuits, emphasizing the importance of testing at all levels.
Unit testing, integration testing, system testing. A comprehensive approach.
And fostering a culture of testing.
Making it an integral part of those process.
Now let's delve into property-based testing.
Testing those properties of the code rather than specific scenarios.
It can help to uncover those hidden bugs, those edge cases.
Like in those warehouse management system, ensuring the total quantity is never negative.
Exactly. Or that each item has a unique identifier.
Property-based testing helps to ensure that our code is robust and reliable.
Now, onto a topic that's crucial in today's world. Security. They emphasize a security-first mindset.
Building security into the design from the start.
And dispelling the myth of security through obscurity.
Hiding those vulnerabilities is not a solution.
They discuss those basic principles. Minimizing attack surface, least privilege, securing defaults, encrypting data, keeping everything updated.
Being proactive, staying ahead of those threats.
Security is an ongoing effort.
Now, for something that often gets overlooked, naming.
The importance of choosing those right words for variables, functions, classes.
It's more than just aesthetics. Good naming can improve understanding.
And they stress consistency, clarity.
Writing code for humans, not just machines.
Code is communication.
Now, for those process of keeping code clean and healthy, refactoring.
Improving those design without changing those behavior, like those home renovation projects.
They emphasize small steps backed by those tests. Refactor early, refactor often.
Manage technical debt, prevent code rot.
Now let's talk about a popular development methodology, test-driven development.
GDD. Write those tests first. Helps to clarify those design and ensure those code meets those requirements.
But they caution against treating TDD as those dogma.
It's a tool, not a rule. Use it wisely.
Now on to component-based development.
Building software from reusable components, like those Lego blocks.
They compare it to those way integrated circuits are built.
Emphasizing those need for thorough testing at all levels to ensure the reliability of those whole system.
It's like ensuring each Lego block is strong and well-made before you build a giant castle.
Exactly. Now let's explore property-based testing.
Testing those properties of your code rather than specific scenarios.
It's like ensuring the total quantity in a warehouse is never negative.
Or that each item has a unique identifier.
Property-based testing helps to catch those subtle bugs.
Now on to those ever-important topic of security.
They advocate for a security-first mindset,
Baking security into those design from those start.
and they debunk those myths of security through obscurity.
Hiding your vulnerabilities is not a solution.
They discuss minimizing attack surface, least privilege.
Securing defaults, encrypting data, keeping everything up to date.
It's about being proactive, staying one step ahead.
Because those security landscape is constantly changing.
Now, let's talk about something that often gets overlooked. Naming.
It can be surprisingly difficult to choose those right names for things.
But good naming is crucial for code readability and maintainability. They emphasize clarity, consistency, and avoiding those overly clever or obscure names.
Now, for those art of improving those design without changing those behavior, refactoring, like those home renovation project.
They recommend small steps, backed by those tests.
Refactoring early, refactoring often, manage those technical debt, prevent those code rot.
It's all about making those code easier to understand, easier to work with.
So refactoring is like an investment in the future of your code base.
Yeah, exactly. It's about preventing those technical debt from spiraling out of control.
Now, speaking of teamwork, the book challenges those traditional approaches to collaboration.
Yeah, all those heavy documentation and those endless meetings
They advocate for a more hands-on approach,
where developers actually work together, side by side.
solving problems collaboratively.
Like pair programming, mob programming.
So less talk, more code.
Exactly. Pair programming is like having a constant code review partner,
Two minds working together.
and mob programming takes it to another level.
The whole team working on the same thing. That sounds intense.
It can be,
Yeah.
but it can also be incredibly effective.
For solving those tough problems and building a strong team dynamic.
Now let's talk about something that can be a bit of a pain point. Requirements.
Requirements, those things that always seem to change.
Exactly. The book debunks the myth of the perfect requirements document.
Because in reality, things evolve.
Client needs change, new information emerges.
They give the example of free shipping.
Seems simple enough, right?
But once you start digging into the details,
All those edge cases pop up.
like what products qualify, are there any exclusions?
Exactly. So requirements gathering is an ongoing process.
A dialogue, not a monologue.
Use mockups, prototypes.
Get feedback early and often.
Now, zooming out to the bigger picture. Pragmatic teams.
Applying those same principles to the way teams function.
Avoid those broken windows. Watch out for those boiled frog scenarios.
Manage the team's knowledge portfolio.
It's all connected.
And finally, a really interesting concept. Sign your work.
Ah, yes. A call for craftsmanship and responsibility.
It's about taking pride in your code
Striving for quality, leaving your mark.
and considering the ethical implications of your work.
The software has a real impact on the world.
And we as programmers have a responsibility to use our powers for good.
Absolutely. So there you have it.
A whirlwind tour of the Pragmatic Programmer.
Full of wisdom and practical advice that can help any developer.
Thanks for joining us on this deep dive.
And until next time, happy coding.
Keep those pragmatic principles in mind.